Section 4.4, Evaluating Logs and Using Change of Base Theorem. First of all, we're going to talk about the common logarithm. Anytime you see log of something, like log of x written, and there is not a base written on the log, then it's understood to be 10. So log base 10 of x is what that is equal to. Common logs are easy to use because your calculator has a log button on there, and anytime it's a common log or log base 10, we can use that log button. However, if your problem is like log base 2, then you cannot use that log button. So example 1, let's practice evaluating some logs that are all base 10. We have log of 1,000, which equals 3. We have log of 42, which equals about 2.15. And we have log of 0.005832, which equals about negative 2.23. Make sure that you actually plug these three problems into your calculator to practice using your calculator for evaluating logs. We're going to look at an application in this section about the pH value of a solution. So the formula we have is pH equals negative log of H base 3 O to the plus sign. So that's hydronium ion concentration. I hope I said that right. Okay, so we can use this formula. We can plug in our hydronium ion concentration into this formula, and it's going to give us out our pH level. pH ranges from 1 to 14. So if we get out a pH of 1, that means that our solution is acidic. 14 would be a base or an alkaline, and then 7 would be neutral, so like water is neutral. Example 2, part A, let's use that formula, and we're going to plug in 2.5 times 10 to the negative 4. And then we can put that in our calculator and evaluate, and we get a pH level of approximately 3.6. Again, we can use our calculator. We can use the log button on our calculator because this formula uses a log base 10. Example 2, part B. This time we're going to find the concentration when our pH is 7.1. So in my equation, I'm going to plug 7.1 in for pH. And now we're going to solve for the hydronium ion concentration. Start by moving that negative over that's in front of the log. So we're going to divide both sides by negative 1. And now anytime we're solving for something that's inside of the log, so it's in the argument of the log, we're going to need to change forms. So right now we're in log form. We're going to change it to exponential form. First of all, we need to figure out what our base is. Since there isn't a base written, we know that that's going to be 10. So to write it in exponential form, we take that base of 10 and our exponent, which is negative 7.1, and set it equal to the argument. Now, if I put 10 to the negative 7.1 in my calculator, I'm going to get a decimal. Got 7 zeros here. And then to write that in scientific notation, I'm just going to move the decimal to the right 8 times. So it's going to be 7.9 times 10 to the negative 8. Again, I get that 8 because I moved the decimal over 8 times. Example 3. Wetlands are classified as bogs, fens, marshes, and swamps based on their pH level. A pH value between 6 and 7.5 indicates that the wetland is a rich fen. When the pH is between 3 and 6, it's a poor fen. And if the pH falls to 3 or less, then the wetland is a bog. Suppose that the hydronium concentration of a sample of water from a wetland is 6.3 times 10 to the negative 5. How would this wetland be classified? So we're going to take 6.3 times 10 to the negative 5 plug it into this equation, and then we're going to decide with the pH level that we get which category this wetland falls into. So we'll start by plugging in 6.3 times 10 to the negative 5. And then we'll type this in our calculator, and we get approximately 4.2. Since the pH is between 3 and 6, it's going to be a porphin. Example 4, measuring the loudness of sound. The loudness of sound is measured in decibels. We first assign an intensity of I naught, that's I with a little 0 at the bottom, to a very faint threshold sound. So that's like the lowest intensity that you can hear with your ears. If a particular sound has intensity I, then the decibel rating D of this louder sound is given by this formula. Find the decibel rating D of a sound with intensity 10,000 times I naught. Okay, so in this problem we're solving for D, and we're going to plug in 10,000 times I naught for our I value, for intensity. Okay, the first thing I notice is in that fraction, I have I naught, so that's the I with the little 0 as a subscript. I have that on the top and the bottom of the fraction, so I know that I can cancel those out. So now I'm left with 10 log of 10,000. Since it is a common log, base 10, I can just type that in my calculator, and I get the answer of 40 decibels. The other type of log that we have that we use a lot in math is a natural log. So we denote natural log as ln of x. So ln of x is equal to log base e. E is a number, just like pi. And we do have an ln, a natural log button on your calculator, so make sure that you find that on your calculator. Example 5 is here for you to practice entering in different natural logs into your calculator. So try natural log of e to the third, natural log of 142, and natural log of 0.005832. Plug those in your calculator and make sure that you get these 3 answers out. Next, we're going to talk about the change of base theorem. So sometimes you need to evaluate a log that's not base 10 or base e. So then we technically couldn't use the log buttons in your calculator. Well, we can take a log like log base a of x, and we can change its base to anything we want, whether we want it to be 10 so that it's a common log, or e so that it's a natural log. The way we do that is we take whatever's in the argument, so this number, and it goes on top of the fraction, and then we take whatever the base is, so a, and it goes on the bottom. And then we are able to use any number that we want for the base. Now, don't go making those bases 6s. That won't work for your calculator. But if you rewrite them as either base 10 or base e, then you could use your calculator to evaluate. We'll do some examples. Example 8, part A, we're going to evaluate log base 5 of 17. So again, looking at our calculators, we can't use the log or the ln button to evaluate this because it's base 5. So what we're going to do is we're going to use change of base. The 17 is going to go in the numerator and the 5 is going to go in the denominator. So we've got log of 17 divided by log of 5. Now a minute ago I told you we can change to whatever base we want. I didn't write a base in that step because I changed it to base 10. Now technically you could come in here and you could write 10, but you don't need to. So now I'm putting in my calculator log of 17 divided by log of 5, and I get 1.7604. Don't forget to round your decimal places to 4 spots. Example 8, part B. So again, we can't put log base 2 in our calculator, so we're going to use change of base formula. So we're going to rewrite this as log of 0.1 on the top divided by log of 2. Both of these are base 10, so I can now use my calculator. When I plug that in and evaluate, I get negative 3.3219. Now we can make a note here. I could have changed them both to natural log. So we could have put in our calculator ln of 0.1 divided by ln of 2, and we would get the same answer. So for change of base, it doesn't matter if you change it to a natural log or if you change it to a common log. Either way, you can use your calculator at that point.